What we've seen so far is this: 3I Atlas accelerated at the right moment, by the right amount, in the right direction, to shift its trajectory into near-perfect alignment with Jupiter's Hill radius. Is this impossible? No. Is it improbable? Extremely. Now, before we continue, there's something critical you need to understand, something NASA did not emphasize in their briefing. A comet does not need to adjust its path constantly to appear controlled. A single adjustment, one well-timed burst, can alter its trajectory for millions of kilometers. In space, small nudges propagate into massive course changes over time. That's basic orbital mechanics. So the argument that 3I Atlas isn't making repeated adjustments doesn't actually weaken the possibility of intentional behavior. If anything, it aligns with it. Because efficiency would require only one meaningful maneuver. But again, we're not claiming intent. We're claiming that the data demonstrates precision, and precision demands explanation. Now, let's take this deeper. Imagine you are an advanced civilization. You want to study a solar system without being detected. Where would you send your probe? What would you target? Not Earth. Earth is noisy. Earth is watched. Not the Sunday. Too dangerous. Not the asteroid belt. Too small scale. You'd target Jupiter, the engine of the solar system. It's a magnetic field. It's gravitational harmonics. It's the radiation environment. Everything you learn from Jupiter teaches you about the structure, stability, and long-term evolution of the entire system. So if someone or something were studying us, Jupiter would be the place to begin. But again, let's stay grounded. We don't need extraterrestrial explanations to justify investigation. We just need the data. And the data shows 3I Atlas is heading toward the most gravitationally meaningful location in the Jupiter system. It is doing so with precision that strains natural randomness. And the forces influencing it include both gravitational and non-gravitational components. That combination is enough to justify scrutiny, not speculation, but scrutiny. Now, let's look at the next layer: timing. Why now? Why this trajectory? This is where the story gets even more interesting, because the acceleration event that shifted 3I Atlas toward Jupiter did not occur at a random point. It occurred at the location where a maneuver would be most efficient. That is not the signature of chaos. That is the signature of optimization. Again, this does not prove anything artificial. It does not justify jumping to conclusions, but it does justify paying attention. And that is exactly what NASA did not communicate clearly enough in their briefing. They focused on reassurance, not on transparency. They emphasized normalcy, not anomalies. And that, more than anything, is what triggered Loeb's critique. Not because he believes 3I Atlas is artificial, but because he believes the scientific community should take anomalies seriously, and on that point, he is undeniably correct. Because when you're dealing with an object that behaves in ways that strain natural explanation, the responsible scientific response is not to minimize those behaviors, but to investigate them. Not to close the door on possibilities, but to widen it long enough to see what the evidence actually says. And that brings us to the next phase of this unfolding story: the internal divide within the scientific community itself. Some astronomers look at 3I Atlas and see nothing more than a comet with unusual features. Others look at the same data and see a pattern of precision that demands deeper scrutiny. The split is not about belief. It's about interpretation, and interpretation is shaped by a philosophical approach. There are two major camps here. This group believes natural explanations must be exhausted before alternatives are considered. Their mindset is grounded in history. People have misinterpreted anomalies before. Strange data often becomes ordinary with better observation. The universe produces weird behavior all the time. This is a valid approach. Science should not leap to extraordinary conclusions. This group argues the opposite. When anomalies pile up, when patterns emerge, when probabilities collapse into improbability, you don't ignore it, you investigate it. This group doesn't claim 3I Atlas is artificial. They claim that dismissing the anomalies prematurely is intellectually dishonest, and they have a point. Now, let's return to the object itself, because the behavior of 3I Atlas during perihelion is the strongest piece of evidence that something more than random chance may be involved. When the object passed behind the sun, hidden from Earth for weeks, something happened, something measurable, something significant. A course correction, not a minor wobble, not a random drift. A measurable acceleration in a direction that just happens to shift its trajectory directly toward Jupiter's Hill radius. And here is where the Minimax pause belongs, because this moment matters. No one saw what happened behind the Sunday. We only know the outcome before perihelion trajectory misses Jupiter's Hill radius. After perihelion, trajectory intersects it with surgical precision. That difference is not speculation. It is math, published, repeatable, publicly available. Anyone can verify it. So the question becomes, what caused it? NASA says, probably natural outgassing, random jet activity. Comets do weird things after perihelion. Loeb says, not so fast. Random processes do not typically result in precision. Randomness does not normally produce targeting. The debate is not about aliens. It's about methodology. And this debate is intensifying with every new data point we collect. NASA's own Mars Reconnaissance Orbiter captured images showing a forward-facing glow, brightness ahead of the object rather than behind it. Normal comets glow behind themselves because their tails stream away from the Sunday. But 3I Atlas shows brightness in the direction of travel. NASA called it interesting. Loeb called it inconsistent with cometary physics. Both statements are true. But only one of them asks the next question. Why 3I Atlas reflects light in a way unlike any comet ever measured? Extreme negative polarization in magnitude never recorded before, opposite of what dust-filled comas normally produces. Natural explanation? Possible. Common? Not remotely. This is not a small deviation. This is an object refusing to fit the template. Nickel and iron are cosmic siblings. They form together. They appear together. They stick together. Finding nickel without iron is like finding salt without sodium. Natural explanation? Yes. Likely? No. For a comet producing the amount of visible activity 3I Atlas displays, the water signature is unusually low. Either the object is water poor, or the jets aren't powered by water. Both explanations strain natural models. Normal comet jets change with rotation, vary with sunlight exposure, flicker, and shift at. Jets on 3I Atlas, more stable, more directed, less dependent on rotation. This is what engineered thrust would look like. But again, it could be natural, just unusually natural. Individually, each anomaly is explainable. Collectively, they form a pattern. A pattern that does not break the laws of physics, but challenges our assumptions about how interstellar objects behave. A pattern that should compel investigation, not dismissal. Which brings us to the fundamental question this entire story has been building toward. What happens in March 2026? That moment, that intersection. That razor-thin window of gravitational precision is the key to everything. Because when that moment arrives, March 2026, one of three things will happen. And each outcome carries a different weight, a different implication, a different chapter in the story of how humanity confronts the unknown. If the object intersects Jupiter's Hill radius with the same razor-thin precision that current calculations suggest, then that is data we cannot ignore. It means the perihelion acceleration wasn't random. It means the subsequent trajectory held steady for months. It means a 1 in 26,000 coincidence actually occurred, in a way that just happens to mimic controlled navigation. This does not prove technology, but it elevates the discussion from possibility to probability is worth serious investigation. If the object arrives nowhere near the predicted location, then we learn something equally important. Natural cometary outgassing can produce wild unpredictability. Acceleration models might be incomplete. Our assumptions about interstellar objects may be overly simplistic, and in that case, the natural explanation becomes much stronger. No extraordinary implications, just extraordinary lessons about comet physics. This is the scenario that turns debate into revelation. If the object releases secondary bodies or changes course again, shows new non-gravitational acceleration, demonstrates propulsion, alters its brightness in structured ways, or does anything inconsistent with cometary physics, then we are no longer discussing coincidence. We are discussing evidence. Evidence of intention, evidence of capability, evidence of something that is not behaving like a comet. This is where scientific responsibility becomes critical, because we are not passive spectators. We are observers, and observation determines the quality of truth. Right now, our data is fragmented, incomplete, opportunistic, scattered across wavelengths, limited by telescope schedules. This leaves ambiguity wide enough for natural and technological interpretations to coexist. But this window has not closed. There is still time to collect continuous photometry, multispectral spectroscopy, infrared thermal maps, high-resolution imaging, radar echoes, if close enough, JWST infrared signatures, coordinated monitoring campaigns, all before March 2026. If and only if the scientific community treats this object not as routine, but as worthy of systematic study. Not because scientists are incompetent, not because NASA is hiding anything, not because anyone is covering up data. The truth is simpler and more human. Institutions fear being wrong more than they fear missing something important. NASA remembers the Venus phosphine embarrassment, the arsenic life fiasco, the false exoplanet biosignature claims, decades of SETI false alarms. So the instinct is downplay, normalize, avoid risk. But risk avoidance is not the same as scientific rigor, and minimizing anomalies, it is not the same as explaining them. Regardless of what 3I Atlas turns out to be, natural or technological, this moment matters. Because this is humanity learning how to confront a cosmic unknown without superstition, without hysteria, without denial, but with curiosity, with skepticism, with evidence, with honesty. We do not know what 3I Atlas is. We only know what it is doing. And what it is doing defies comfortable categorization. You are not a passive audience. You are part of the reasoning process. When you comment, when you question, when you share analysis, When you demand transparency, you shift public attention, and public attention shifts institutional priorities. This is not sensationalism. This is participation in real scientific scrutiny. What do you think the data actually suggests? Not what you want to be true, what the evidence points toward. This isn't about abandoning scientific models. It's about recognizing when accumulated deviations suggest the model itself needs revision, rather than the data needing reinterpretation. The path forward from here requires something we're often reluctant to embrace: genuine open-mindedness. That doesn't prejudge the answer, but follows evidence wherever it actually leads. That means not assuming this must be natural, because technological explanations feel uncomfortable. It also means not assuming this must be technological, because that would be exciting. It means looking at what we observe, testing different explanations against that evidence, and assigning probability based on which explanation requires fewer assumptions and better fits the full data set. Right now, the honest application of that standard leaves both possibilities in play, with a technological hypothesis gaining weight from the precision and anomaly accumulation, while the natural hypothesis retains viability through our incomplete data and the general principle that extraordinary claims demand extraordinary evidence. If 3I Atlas reaches Jupiter's Hill radius, exactly as predicted, arriving at that gravitationally significant boundary, with the precision current calculations suggest, that's a result requiring explanation, regardless of philosophical preferences. If it arrives and does something obviously anomalous, releases objects, demonstrates additional propulsive capability, changes course in ways that definitively rule out natural explanations, then we're past the point of debate. But even if it simply arrives as predicted and then continues onward, never doing anything unambiguously technological, the precision of that arrival, within such tight margins, there remains evidence demanding interpretation. A 1-inch 26,000 coincidence happened to produce an outcome that looks exactly like targeting. Science doesn't advance by shrugging at such coincidences. Every additional data point we gather makes the eventual interpretation more robust. Every measurement we fail to make leaves ambiguity that could have been resolved. The question isn't whether we'll watch what happens. In March 2026, people will pay attention. The question is whether we'll study the object systematically. In the months leading up to that moment, gathering the kind of comprehensive characterization that would let us distinguish between hypotheses with confidence. The answer depends on whether institutions allocate resources, whether researchers coordinate efforts, whether the scientific establishment decides this deserves priority attention. For those of us not operating research telescopes or planning space missions, the role is different, but not insignificant. Public attention matters because it influences institutional priorities. When people care about something, ask questions, demand answers, and make it clear that scientific curiosity about this situation is widespread and genuine. It creates pressure for appropriate investigation. This isn't about mobilizing masses or demanding specific conclusions. It's about staying informed, engaging with the actual evidence, rather than sensational headlines. It's about building a community that values real inquiry over comfortable narratives. Bring this analysis to people who think carefully about evidence and interpretation. Discuss it with those who understand that genuine mystery is more valuable than premature certainty. Comment with your own assessment of the evidence, not what you hope is true, but what the data actually supports. Subscribe to channels and sources that prioritize substance over clickbait, those willing to say we don't know yet when appropriate, but also willing to ask uncomfortable questions when evidence justifies them. Turn on notifications because this story will continue unfolding, and what we learn between now and March 2026 might shift the interpretation significantly in one direction or the other. The broader significance of this situation transcends 3i Atlas itself. How we investigate, interpret, and communicate about it sets a precedent for how we'll approach future encounters with the unexpected. If we do this well, study systematically, think carefully, follow evidence honestly, we show that humanity is ready to confront genuine cosmic mysteries with maturity and rigor. If we do it poorly, dismiss anomalies reflexively, or sensationalize them irresponsibly, let ideological commitments override analysis, then we demonstrate that we are not yet ready for the universe's complexities. There is something profound about living through a moment when answers are still pending, when we exist in the space between question and resolution. March 2026 will come. We'll see whether predictions hold or fail. We'll gather new data that moves us closer to understanding what 3i Atlas actually is. But right now, we exist in genuine uncertainty, and that uncertainty is not weakness. It is an opportunity. Opportunity for deeper inquiry, better data, honest debate, open-minded reasoning. Some mysteries deserve investigation rather than premature conclusions. Stay curious, but skeptical. Demand evidence, but remain open to what that evidence suggests, even when it's uncomfortable. Don't accept either extreme, not the reflexive dismissal that says this can't possibly be technological, nor the uncritical excitement that insists it must be. Look at the numbers. Consider the probabilities. Think about how anomalies accumulate. Recognize that whatever the truth is, we're living through a moment where humanity is grappling with something at the edge of our understanding. Something that will not be resolved by comfort or preference, but only by evidence and honest thought. This catalog isn't complete. New observations continue to generate new data. And some of what we currently think we know will be refined or corrected as measurement precision improves. But the pattern is established and growing stronger rather than weaker. The more we look at 3i Atlas, the more it resists fitting into the comfortable categories we'd like to place it in. And that resistance to categorization is itself meaningful. It's a signal that something about our understanding is incomplete, whether that incompleteness lies in our models of natural cometary behavior or in our assumptions about what moves through interstellar space. Then what would a technological explanation actually look like in practice? What specific capabilities would be involved? What mechanisms would it produce the observed characteristics? And why would something with those capabilities? Are you interested in Jupiter's gravitational boundary? Let's be precise about what we're discussing. When we talk about a technological interpretation, of 3I Atlas. This isn't about fantasy. This isn't about fiction. This is about examining what characteristics would we expect to see if an object were demonstrating controlled interstellar navigation, and then comparing those expectations against the observed data. If 3I Atlas were capable of adjusting its trajectory, what would that look like to our telescopes? You wouldn't expect glowing engines or cinematic thruster plumes. You'd expect something subtle. Changes in velocity, non-gravitational acceleration, jets that appear directed matte, slight adjustments that accumulate over time. That is exactly what we observe. The non-gravitational acceleration at perihelion, the collimated jets appearing after perihelion, the resulting trajectory that leads precisely to Jupiter's Hill radius. All of this matches what we'd predict from a propulsion system operating at the threshold of our detection capabilities. If you wanted to alter a trajectory with maximum efficiency, you'd perform your burn deep in a gravity well, where the Oberth effect multiplies thrust. Exactly where 3I Atlas performed its shift. If you wanted to maneuver without being observed by Earth-based telescopes, you'd execute that maneuver when the sun physically blocked observation. Exactly when the course change happened. Coincidence? Possibly. But coincidence after coincidence begins to resemble a pattern. Natural comets glow behind them as dust trails away. But 3I Atlas displays a forward-facing glow, material or energy concentrated in the direction of travel. If a spacecraft were projecting a protective beam to vaporize incoming particles at interstellar speeds, that's exactly how it would appear. If you're a scientific probe entering an unfamiliar solar system, you probably avoid Earth, the brightest, most monitored planet. Jupiter is different. Massive, gravitational anchor, wide, stable Lagrange points, dozens of moons with chemistry worth studying, less constant human surveillance. A perfect observational platform, or staging point. Again, this doesn't prove anything, but it matches an engineering logic that natural explanations struggle to match. The unusual polarization, explained by engineered surfaces. Nickel without iron, explained by selective alloys. Stable jets, explained by directional thrusters. Thermal anomalies, explained by internal power systems. Rapid onset of activity, explained by systems activation. Natural explanations can account for each anomaly individually, but require stacking rare but possible events on top of one another. The technological explanation accounts for all anomalies collectively, with fewer assumptions. Occam's razor doesn't say, assume nature did it. It says, choose the explanation requiring fewer special assumptions. We don't have it yet. No visible artificial structures, no detected radio signals, no clearly non-natural spectral lines. What we have is behavior that matches controlled navigation and characteristics that strain natural interpretation. The threshold of extraordinary evidence is subjective, but the accumulation of indirect evidence grows heavier every month. Not, what do you want this to be? Not what would be exciting. But, which explanation requires fewer improbable coincidences? Right now, Honest Bayesian reasoning gives weight to both possibilities, but the technological hypothesis is gaining probability because it explains more with less strain. If 3I Atlas reaches the Hill radius exactly as predicted, that is a data point with historical weight. If it deviates wildly, that is also data. If it does something unexpected, that is a turning point for human civilization. Even with everything we've discussed, there's a massive caveat that intellectual honesty requires us to address. The data we have on 3I Atlas, while intriguing, is fragmentary. Our observations are not the product of a coordinated, comprehensive study. They're scattered snapshots, moments captured when telescopes happened to be pointed in the right direction. This creates ambiguity wide enough for natural and technological explanations to coexist without definitive resolution. The polarization measurements, as shocking as they are, come from limited observation windows. We don't have full surface mapping. We don't have rotation phase coverage. We don't have multi-wavelength polarization. So we can't rule out rare but natural explanations. But we also can't rule out non-natural surface properties. Nickel without iron, low water content, unusual organic ratios. All real observations, but taken during limited windows, under specific conditions, with no continuous spectral coverage. Again, ambiguity. This is the strongest evidence. Hundreds of observatories are tracking an interstellar object with remarkable positional precision. But even here, the perihelion gap haunts the analysis. We know acceleration occurred. We know it altered the trajectory. We know it produced the Jupiter-Hill radius alignment. What we don't know is the mechanism, because the sun blocked observation. Continuous photometry, coordinated spectroscopy, JWST thermal mapping, radar imaging, if possible, uninterrupted multi-wavelength tracking over minute. We're not doing this, not because the science is impossible, but because the system isn't treating this as a priority object. And this is where Lay's criticism lands. Science is failing not through conspiracy, but through institutional inertia. When that date arrives, our options collapse. If 3I Atlas hits the Hill radius with incredible precision, the conversation changes. If it deviates wildly, nature wins. If it does something unexpected, history begins. If 3I Atlas is natural, we expand our understanding of interstellar objects. If 3I Atlas is technological, we answer a question older than civilization itself. If we fail to study it properly, we risk permanent ambiguity about something that should have been resolvable. Future generations might ask, why didn't we look harder when the opportunity was right in front of us? Before blaming the universe for not matching expectations, we must check whether our expectations were reasonable. Our models of comets are based entirely on objects formed in our own solar system. Interstellar objects may be more diverse or more engineered than we assume. Stay skeptical, stay curious, demand evidence, stay flexible. Don't choose comfort over accuracy. Don't dismiss, because dismissal feels safe. And don't accept without evidence, because excitement feels good. Look at the numbers. Consider the probabilities. Understand what an accumulation of anomalies means. The universe doesn't care what we prefer to be true. It simply is what it is. Our job is to figure out what that is as accurately and honestly as we can manage. 3i Atlas is giving us a chance to do exactly that. Let's not waste it. Thank you for watching VERTEX, your home for deep, honest journeys into space, science, and the mysteries shaping our universe. If this breakdown of 3i Atlas made you think differently about what might be happening in our own solar system, make sure to like this video so more curious minds can find it. If you believe this subject deserves real scientific attention, not silence, and not dismissal, hit subscribe and turn on notifications. Because we're going to follow 3i Atlas every step of the way until the moment of truth in March 2026. Let me know in the comments, do you think 3i Atlas is natural, or could it be something more? Your voice matters. Until next time, stay curious, keep questioning, and remember, the universe doesn't wait for us. It simply reveals itself to anyone who's paying attention. This is VERTEX, signing off.